all here, and thanks for coming. Sorry that I didn't warn you in advance that we'll be recording sessions. Well, that's a technical problem here. Okay, I'm delighted to open our regular Masters Symposium. I'm also delighted to invite our invited supernova, the first vice rector of Ukrainian Catholic University, Mr. Professor Yaroslav Pritula, to create the symposium. In a way, he always does this. This is impeccable as always. Please meet him and applaud.
Thank you, Vadim. Thank you, friends. In the program, I'm named as General Chair. I'm very general chair. Yeah, and I'm really glad to stay here in front of other chairs and say that I'm proud of you, because I look through the program and I see that the topics you raise, the number of topics, number of participants of this symposium is the greatest for the 4 last years. Actually, congratulations, this is our first anniversary, fifth symposium. And it's not only that topics are great and a number of people, but this shows the potential of our program. It shows the potential of you. And I think you know, but I want to say it again. You are very in demand in this world. You are in demand for our country. And please proceed with the same speed as you did it through your study at our master program. So good luck with 2 days of really great discussions. And I wish you luck during your personal presentation at this stage. And I wish you luck in the future with your future research. Thank you. And also congratulations to the organizers for such a great program.
Thank you very much. I'm also delighted to invite the local organization chair, who is also a superstar here, is directing your program, Mr. Ruslan Partsay. Could you please say a few words to the audience?
Yeah, thank you, Vadim, for the introduction. To be honest, I didn't prepare a speech. Yeah, so I'm a little bit nervous, but I'm happy to see all of you here and happy that you made it so far, that actually you reached half the way before you defend your master thesis. And just to give you a little bit of the context that yes, so this is the fifth symposium, but I guess this is the third, or this is the third offline event, because past 2 or 3 were online. So I'm very happy that we can meet in person and you can present in person and you can, do a test run of your research project. And I'm very grateful for all the reviewers that reviewed your submissions, that found the time to review and give a feedback. Grateful to organizers, grateful to them for leading this organization effort. Yeah, so this year we have around 30 submissions, and this is very high number compared to other years. And yeah, good luck everyone, and looking forward to hear your presentations.
As you might know, Vadim is me. Thanks for greeting. I would also like to welcome our program committee members who helped us enormously in selecting the very best papers, in writing great and detailed reviews, which, as I believe, helped you a lot. Some of the PC members even managed to join us in person, so I'm happy to introduce our invited star, Dr. Igor Krashny. Welcome, please. And our professor star. I'm just inventing, as you know, I'm just inventing the duties and the roles. The professor star, Professor Rostislav Krinev, who also made a lot to contribute to the quality of the program. Oh yeah. I also believe that all of the stars sitting over there are well known to you. Okay. Some technical comments, if you please allow me. So we are proceeding very closely to the program. So we will be announcing the talks as scheduled in the program. You will be having 20 up to 24 minutes at the maximum, just leaving the rest of the slot for the questions and answers. So please stick to the time slot in order to not introduce any delay or inconvenience for the rest of the speakers. So we'll be having chairs who will introduce the speakers and inviting you to the podium. Before starting your talk, we'll be asking you to join the Zoom session, and the link is available at the symposium website, just in order to enable our virtual guests to see and hear your presentation. So this is it. And if you, about the numbers, we do had 27 submissions, which is an increase compared to the previous years. We have accepted 25 best quality submissions. Some of them have been accepted conditionally, and we are looking forward to see improvements in the camera-ready papers. We'll be looking at these immediately after the symposium and let you know if any improvements in the camera-readies will be necessary from your side. Okay, I'm appealing to you to react constructively and help us correct the imperfections in formatting, for instance, or in any other things which our proceedings chair will be requesting from you. Okay, thank you very much. So, if you have any other procedural questions, please go ahead. It's the right time to ask. No? Thank you. So we have 7 lovely minutes for the first speaker to prepare for the talk. And the rest may enjoy a small break and go out to the IT space where the coffee breaks will be served by the way. Just look into the program. If you notice this keyword, coffee break, it means that there is some coffee and some cookies over there. So please enjoy. Dear ladies and gentlemen, you're very welcome to our first session in the program of the Master's Symposium. Our first session is focused around large language models, information retrieval, and natural language processing. I'm very happy to introduce our pioneer speaker, the first guy who will be opening the symposium, which is a very important duty. Thank you. So I'm happy to introduce the first talk given by Yevhenii Sapolovych, entitled Classification of Ukrainian News with Scarce Labeled Data. This work towards the master's degree has been advised by Professor Oleksii Ignatenko of Ukrainian Catholic University. He apologized, by the way, that he was not able to join us right now because he's having classes. So, Yevhenii, podium is yours. Please go ahead, and we're looking really forward to your delighting talk.
Good morning, everyone. Thank you for coming. Today, I will present my research project called Classification of Ukrainian News with Scarce Labeled Data. And I hope you will enjoy this short presentation. First of all, I would like to express my gratitude to my advisor, Oleksii Ignatenko, who helped guiding me and assisted me throughout this research effort. So shortly on the plan, I'll start with my motivation and research goal, give a little overview of the current state of the field, talk about research gaps, questions, and a problem, provide a suggested approach to solution, talk a little about the data set for this work, present experimental setup, then early results, and conclude my presentation. So to start with, text classification is a very important task in natural language processing, and it encapsulates many different problems like natural language inference, sentiment analysis, text categorization, and so forth. And so the fundamental issue of it, and like many other machine learning algorithms, is that it requires large training data to generalize well on previously unseen data and predict correctly. And so in real life, low data scenarios are quite common because labeling data may be too time consuming or too costly, or the data is distributed in such a way that there are rare classes. And so to mitigate this issue, large effort has been put into a setting called few-shot learning, which aims at training efficient models and algorithms that can generalize well on unseen data without large training data. And so much effort has been put into few-shot text classification in English, but not so much into other languages, except probably Chinese, still less than English. And that includes Ukrainian, which is, of course, my primary language of interest. Given all this, my research goal, the research goal we set is to provide a robust few-shot classifier for the Ukrainian language with an accuracy 85% plus that would work on a moderately complex task. So not a binary classification, but something more complex with a small training set ranging from 8 to 16 examples per class. Shortly about the current state of the field. Most of the recent works, by which I mean past 2-3 years, rely on pre-trained language models and prompts. As you may know, pre-trained language models come in different flavors. There are so-called masked language models, for instance, like BERT, and large autoregressive models, also known as large language models in general, like GPT 3.5. And so the techniques used to classify text in a few-shot manner with those differ quite a lot. For instance, with a mask language model, as you can see from the illustration in the top right corner, a word in a sentence is put into a model. It is prepended by a so-called pattern, like it was, and a mask token, which the model has to predict correctly. When the model does, for instance, in this case, it was great. It needs to be mapped to one of the classes from the data. For instance, grade should be positive. And when it comes to large language models, a typical technique is an in-context learning, or ICL, which works like this. So the examples of text are provided, appended with labels, for instance, two examples per class, and then the final text is provided without a label, and the model outputs the label which it assumes is correct. These are the two most basic and prominent methods for text classification using language models. It should be noted that they typically provide good performance. They mitigate the need to invent architecture from ground up, because you typically only need to change a couple final layers of the model. But at the same time, they incur high training and inference costs. They are not language agnostic, and prompts for them are quite hard to craft. So far, there's been quite a few alternatives and side grades suggested. Some do not use pre-trained language models, which of course primarily results in worse performance. Some use continuous trainable prompts. Some try to automate prompt selection. Another way is to use adapters inserted in the model and trainable label embeddings, or to solve the issue of high inference and training costs. Some try to use lighter models. There are quite a few methods for classifying text in few-shot setting with pre-trained language models, but in general, there is no single optimal strategy, because all of them provide different trade-offs between performance and computational complexity, and there's no definitive state of the art, as there is no like a single all-encompassing benchmark, and all the papers report different results on different data sets, which often do not overlap. So this kind of hinders comparability and does not allow to just select one great solution for all cases. Another issue worth mentioning is that some papers on the subject use large validation sets for selecting hyperparameters or prompts. And in general, these validation sets, well, they're not available in a true few-shot setting. Well, it has been shown that these are not mandatory. Small validation sets are still viable, but in general, a larger validation sets ensures that your model, you may select a better model or a better prompt, and the results are better. Having said that, I would like to outline the research gaps. So the first one is that in the light of absence of prior works for Ukrainian, it is not apparent which existing solutions are adaptable to the language. We should consider that the selection of language models is much more modest compared to English, that some available multilingual models may perform worse than their unilingual counterparts, and there are no specific language resources required by some methods to work, like knowledge bases required for composing prompts. And what can we offer is extensive research, search and research and experimentation with the available options. Secondly, again, as there are no prior works we know of, there are no existing baselines. So we need something to compare our primary solution to. And this calls for selection of the most promising methods and creating baselines that would be sort of a foundation for our and future research. And thirdly, it should be noted that computational costs of these algorithms are typically not considered or of secondary importance in these papers, but in reality, they restrict applicability. As I said, language models tend to be quite large, and they require powerful graphic processor units to run efficiently and fast. And for another thing, large validation sets violate low data assumption. So to address that, we would like to test multiple methods, including those applicable in low resource scenarios, without much computational power and without large validation set available. And so this leads us to the research questions. The first one is how adaptable existing approaches to Ukrainian? Is efficient low research fuchsia text classification possible? And can a method with modest hardware requirements compete with a large PLM, by which I mean a gap of 5% in accuracy or smaller? Our research problem is we need to satisfy a solution and provide a methods that would work under different conditions and provide a good trade-off between computational complexity and performance. Now a little bit about the suggested approach. It is based upon a method and a Python library called setfit. Setfit is a language model-based method for fuchsia text classification, but it does not utilize prompts, and it consists of two components. The first is a sentence transformer body, which is a light transformer model, which encodes sentences or larger text if the context length allows to fixed size continuous vectors. And the model works like this. So first, a text is converted to a vector. Then the model is trained on a cosigned similarity loss function to pull instances of the same class closer and to pull instances of different classes further apart. And after the model body has been trained, the outputs, the produced vectors, are fed into a classifier. In this case, it is a logistic regression. We will use setfit, the vanilla setfit, as one of our baselines, but at the same time, we suggest several modifications which are meant to improve the performance. Firstly, we acknowledge that the main bottleneck in our setting is the lack of training examples, and so we are going to produce artificial examples to solve that. Firstly, we are going to use a large language model to generate more class instances. And secondly, we're going to use segmentations, namely linear combinations of embedding vectors fed into the classifier, which is a technique used in a paper called mixed text, which has shown to be quite robust. For another thing, we will train multiple model generations. This is based on an assumption that there is available unlabeled in-domain data, which we can take advantage of. So firstly, a model is trained on a small set of training examples. Then it is used to label unlabeled examples, and the examples with the highest confidence are added to the training set, and so the second generation of a model is trained. This process is repeated until there is no improvement in accuracy. And another thing that we are going to try is chunking texts. As I've said, sentence transformer models typically have a limited length of text they can encode, and so to try to mitigate that, we will split text into chunks, which will allow us to classify them separately and then select the class of a final document through majority vote. A couple of words about our data set of choice. It is called UA News. It is quite similar to a popular English benchmark called AG News. It contains news from various online websites. Unlike AG News, it has not 4 but 5 categories, namely business, politics, sports, and technology. There are 30,000 training examples and 120 test examples in the dataset. But due to very long inference times, we will use about 20% of the test set for our experiments. And as you can see from the charts in the page, the distribution of the data set is imbalanced. So I will return to it in a little bit. Experimental setup. So we will test multiple sentence transformer models and try to select baselines based on a few criteria, namely their reported performance, their computational requirements, and if they are adaptable to Ukrainian or not. And so we are going to try to select diverse baselines. Namely, we will try to incorporate methods with mask language models, with a large language model for in-context learning, and at least one with no pre-trained language model used. We will use training sets containing 8 and 16 training documents per class, and the validation sets of the same size. And we will report multiple metrics. Firstly, accuracy, which is a typical metric used in classification papers. But as I said, our data set is imbalanced. So we also ought to report macro F1 score and weighted F1 score to see an all-around performance. So far, we have chosen the baselines, made necessary amendments and modifications for the code to run. Also, nearly finished writing code to modify our main method setFit, and ran the first experiments, the results of which you may see in this slide. So as you can see, we have used 8 training examples per class so far, except of in-context learning. We used 3 examples per class, 3 news messages per class for Mistral 7B large language model because of the limited prompt size. But so the best result so far has been shown by setFit, yet unmodified, with E5 multilingual small model. The other models have not performed so well, despite some of them being much larger than E5. And so we outlined the goal and the problem of this research. We have made a thorough review of the works and came up with the main approach and baselines. We designed a primary solution in a way that should work well in a low resource setting, at least in a relative low resource setting without a very powerful graphic processor unit. And the first results have been promising as I see it, as we're already close to our desired margin of 85% accuracy. And more experiments are currently underway, and I believe that we are going to achieve much better results ultimately. Thank you very much for your attention.
Thank you very much. And now we're all set to start questions and answers. Any questions from the audience, please? Also virtual guests.
Hello. Can you please show the slide with the chunking and the suggested approach? I have a small questions related how you will find it hollow these chunks, because split it only by the sentences. It will be a bit tricky because it's harder to find this sentiment from the sentences when you will split it, and you need to think with some smarter how to chunk it. And it's like questions. What do you think about that?
Thank you for the question. The idea is to use a tokenizer to measure the text length and then split on tokens, which kind of which are the limit for the model maximum length. And the tricky part here is indeed to make sure that the sentence boundaries are not violated by that. But we're still implementing that, and I will report the final solution later. But so far, it's quite challenging indeed.
Okay, thanks.
Thank you. More questions? I have a technical question. Could you please return to the first slide where you have presented application? Where you spoke about 5 categories of Ukrainian news. Oh, yeah. I was desperately looking for the 5th in the slide. So you just listed 4. Was that done on purpose? Just missed. What was the 5th? Sports. Sport. Okay. Thank you. More questions? Okay. First, I would like to thank the first speaker for saving us some time to extend the coffee break. So therefore, we will start right now, not waiting for the next scheduled time slot for the second talk. And I'm quite happy to introduce our next speaker, Yurii Yelisieiev, who will be speaking about efficient knowledge distillation and retrieval in language models. I'm happy to announce that this work has been advised by Vladyslav Zavadsky, who is our colleague from the Ukrainian Catholic University. So, Yurii, the floor is yours. Please go ahead, and the mic is over there. Just switch it on.
1, 2. So, hello everyone. Today I will present my research on efficient knowledge distillation and retrieval in language models, and this work was done by me under the supervision of Vladyslav Zavadsky. Okay, so let's start with some abbreviations which I will use throughout the presentation. So KD. Okay. KD stands for knowledge distillation, and I assume that everyone knows what does LLM stands for. It's language models, by the way. So RAG stands for Retrieval Augmented Generation, and KG stands for Knowledge Graph. Now let's talk a bit about the presentation outline and the structure of it. We will start with the motivation of our research and set some research goals. Then we will proceed with the analysis of related works, and we will identify some research gaps in current LLM distillation, knowledge distillation field. And then we will talk about the proposed approach and the evaluations. Yeah, our proposed approach actually consists of 3 main parts. It's a construction of the knowledge graph, retrieval augmented language modeling, and knowledge distillation. So let's start with the motivation behind our research. First of all, you all know that the LLMs are pretty huge, and they must be huge since the performance of LLMs actually is very dependent on its size and on the size of the training data sets. But it could be a huge problem if you want to use this model on the end devices, since it requires a large GPU memory, and it cannot be run locally on most of the end devices. And there is actually a reason why they're huge. They encode vast amounts of factual data implicitly. So during the training procedure, they try to predict the next token or mask token. And during this, they're basically learning the language statistics. And in this way, they can learn the factual information implicitly, since they can perform some question answering in zero-shot manner when you just ask them some general question and you expect to obtain an output which describes this general notion. And it's actually, can be a benefit, but it's also a problem, since we dedicate a large portion of our parameters of a language model to memorization and not actual language modeling. And actually, there is one more problem connected with this issue, is that since our information is not encoded explicitly, but is encoded inside the model weights, it can lead to hallucinations during the text generation. And it's a huge problem, since sometimes those hallucinations can be very legit, can look very legit even for some professionals in the field, but it's completely made up. And it's very hard to perform the fact checking of actual information encoded in large language models, since we cannot retrieve all the information which is stored there. And there are some works which are doing it, but they cannot retrieve the whole training data set and all the factual data encoded. And we propose to research the method which disentangles the large language model into 2 separate entities. The one which stores all the factual data explicitly, which we'll call knowledge base or knowledge graph. And we also would like to investigate the process of knowledge distillation together with the external database to obtain a smaller model which doesn't encode any of the factual information, but only operates the factual data, given it as an input from the knowledge graph. Yep, we will start a bit with the LLM background and why we decided to tackle this problem. So first of all, like you all know what LLMs are. There are a lot of variety between LLM architecture, like mostly, but they are all based on they are all transformer based. They actually utilize the same architecture all the time, only with some minor adjustments. But there is actually a law that all you need to obtain a better performance of the LLMs is actually a scale. So you scale the model, you scale the data, and you can achieve a better performance in language modeling task. And it's actually like a problem, since most of the research labs and the corporate companies, they try to achieve like more bigger models, not some architecturally advanced models. And one more point is that all those models learned are statistical models, and they are learning the actual distribution like of the language. So how the on the next token prediction task. And let's talk about the scaling laws of large language models. So the performance of the large language model can be characterized by smooth and predictable function, which is dependent on two variables. It's model size and dataset size. And on the plot on the right, you can see that if you scale only the model size and you're not scaling the training dataset size, on one time, like on some point, this graph might, like the performance might collapse and we can obtain a worse model than before. But if you scale the model size and the dataset size simultaneously, and you can achieve the better performance. And actually, by using this function, we can find an optimal point for the given like performance which we for the given plots which we have. So it's a combination of model size and the training dataset size. So and you can optimize the model size based on the amount of training data you have. But still, if you have larger models and more data, it leads to better performance, and you don't need to scale like to change the architecture much. Yep. And because of this, there is a huge research field which dedicated to knowledge distillation, and they trying to achieve a smaller language model which actually replicates the behavior of the teacher network. And they are just doing it by randomly initializing the student network, which is much smaller, and they learn the student network to output the same distribution as the teacher on token prediction task, and they're doing it just by minimizing the KL divergence. There are a lot of like knowledge distillation setups and objectives which can be used not only for knowledge compression, but also for the expansion, adaptation, or enhancement. But still, it's all the same. They're just using the teacher network without much variety on the architecture of it. Like they can use it for knowledge distillation of intermediate representations or only the output, or they can use a different optimized objective, but the setup stays the same. They always using a larger teacher network. And knowledge distillation in large language models can be divided into two groups. First of all, it's a white box knowledge distillation, and second one is a black box knowledge distillation. And all of the like white box knowledge distillation means that we have a model itself, so it's not a black box. We do not enter the model from the endpoint or the API, and we have actual the model on our server, and we can manipulate the weights, and we can obtain the intermediate representations of the language. And with the black box method, we do not have the ability to operate with intermediate representations, but we are focusing more on like outputs of the model and using in-context learning, chain of thought, or instruction fine-tuning for the knowledge distillation. Yep, and there is a clear research gap in current research on knowledge distillation in large language models, is that they're focusing actually more on the compression of the model, and they're not researching the model decomposition into two separate indices, which actually is a missed opportunity for simplifying their complexity and giving the ability to interpret and add factual information efficiently. And during the distillation process, is oftenly overlooked part that we are using a teacher network which is larger, and in its weights it encodes all the factual data, and it actually influences the knowledge distillation process, since we are optimizing the student output distribution to the teacher output distribution, which is biased to the factual data, like not the direction, but it's biased by the factual data. And we are trying to distill the smaller model, which is actually a problem. It affects the quality of the student model. And our proposed approach, here you can see the high-level architecture. It is basically starts with unstructured text corpus. When we are trying to create a knowledge graph from it. So we are basically searching through entities given in unstructured text and asking the model itself to relate those entities to each other and output a node and relation to the another node to the another entity. And we are utilizing currently the large language model for it. And then after the construction of the knowledge graph, we want to retrieve additional context based on the input. So first of all, we sample two subsequent text passages from the text corpus, and the first passage acts as an input to the large language model, and we retrieve the additional context to the model from our constructed knowledge base and pass it to the student model and ask it to predict the continuation of this passage on beyond the next token prediction task. And during this next token prediction, we are searching for new entities in the generation. And so this dual setup, we are trying to achieve that the model is using the most of the available context, available like knowledge available in our knowledge base. And so they're constantly trying to find the new entity and add it to the context. Let's go through the architecture step by step. So first of all, we want to construct this knowledge graph. And it can be done via some specialized ML model, or we can utilize LLM itself for it. So basically what we're trying to achieve is to extract some triplets is entity, relation, and the second entity. And actually, large language models are pretty clever and they can do it with ease, but the question is how we can interpret the output without additional output parsing or something. So we need to force LLM model to output the structured output as a JSON or some other format to be able to manipulate it efficiently. And it is done by like different methods, but they're mostly just some prompt engineering or some grammar. And additionally, after the processing, like construction of those triplets, we are adding those triplets to the vector graph storage, which is then used to retrieve and augment our model inputs. And then after we like distill, so to say, it's like kind of symbolic distillation of our text corpus into the knowledge graph. We want to train or like to optimize a student model to perform well on next token prediction. And for this, we need multiple things. First of all, it's effective graph querying and effective embeddings in a vector database, since it's very crucial to find the nodes in the graph which are actually pretty relevant to our input efficiently. And additionally to this, we also doing another querying to the graph during the next token prediction task. So we are querying the knowledge base pretty a lot of times during the training. So, and for this, we need the effective graph querying. And this is needed also for dual generation mechanism. But we also thinking about the setup where there is no teacher actually during the distillation, since, as I said, the teacher is biased towards it's not biased, but it's like corrupted by the factual information encoded in its graph, in its weights. So we are just aiming to train a student model which operates on the inputs augmented with additional context. And by this, they actually learning how to operate the factual information given to it without encoding it implicitly in its weights, and just operates the fact like actually learning how to perform the language modeling, not the factual data memorization. And for this task, we do not need a teacher at all. So, and for the evaluation of our method, we chose the most straightforward way is evaluation on question answering benchmark. So we will use the wiki Q&A dataset and calculate some classical metrics for the Q&A. But this approach can be used in numerous tasks, so it only depends on the training dataset size. So we would like to experiment with other tasks itself also, but for this we need larger compute powers. And let's talk a bit why is it hard. First of all, due to the lack of robustness of large language models, there is a huge challenge in knowledge graph construction, because sometimes even the trained, so-called instructed large language models, they also perform some form of hallucination in their output and adding additional fields to the JSON, and it's not very robust. Second of all, there is a critical need to enable the mechanism to enable fast squaring and augmentation of knowledge graph, because we need to create a mechanism for a faster search. It could be done via the embedding search on the vector database, or it can be done via another separated model, which is called a retriever. And there are actually a lot of ways to do it, and they must be evaluated, and we must choose the best one or came up with a new one. So, and the third is that the process demands substantial computational resources, since we are training another smaller language model, which must learn the language modeling from scratch, but incorporating additional context from the knowledge graph. And for some tasks, it can be done on smaller compute powers, but for some larger data sets, we need to do it on a bigger cluster. And the early results of our work is that we actually created a pipeline for knowledge graph construction and experimented with different approaches to obtain a structured output. And now we are experimenting more with it and searching for an optimal way how to for entity identification and relation search. Yep, that's it. Thank you for your attention. If there are some questions.
Yeah, thank you for your talk. I have few questions. So basically, distillation process involves you have large model and you have small model, and during the distillation process, you have the performance degradation for the student model. So what the considerable trade-off do you what the trade-off would be okay for you to say that your method is okay, the difference between the teacher and student?
But actually, in the final slide, we are not using the teacher at all. So we are just learning we distill the knowledge of the teacher of the larger network.
Yeah, but you have the performance of your of the teacher model.
We expect our model to be better or the same as language model we distilled. With such a method, it just the composition of language modeling into two tasks. So it's first the graph construction, and then it's the creation of smaller model. So, and we want to achieve the performance, which is comparable to the actual model used to distill the knowledge.
Yeah, I understand that this should be comparable, but you have the capacity of the model, and it's 10 times less. For example, you have less parameters, so basically you can't fit all that knowledge inside.
Yeah, but since we encoded the large, as I said before, we have the encoded knowledge inside the large language model, and it it's memorized in its weights. And during the if we decompose the knowledge into separate entity, we assume that by this way we can achieve the same performance in language modeling, but the knowledge will be added to it as a context, and by this way there will be no need for the model itself for the student to incorporate this information in its weights, and it would perform the language modeling task the same as a teacher, but without factual data encoded.
Okay, so got it. And the second part, basically of the question, does the architecture of the teacher and the student, they're the same, just but scaled, or it's totally different, or you're not?
We actually didn't we didn't experiment with the distillation process much, since we are now more focusing on knowledge graph construction, and we haven't enough time and resources to experiment with distillation objects.
Thank you.
Thank you. Ruslan?
Yeah, actually, I had a pretty similar questions that Igor asked. Yeah, so my question is that, like, large language models are usually perform a very good zero shot. So they are trained on a vast amount of text, and they can be applied to almost any task described in text. And do you expect to have the same performance in your setup? Like when you construct your knowledge base, knowledge graph from a WikiQA dataset, right? So it will work only on the questions on a domain that is in that dataset. And if I want to, say, scale to other tasks, will it work?
Yeah, I think that our goal, final result of this research and this evaluation will not be able to perform zero shot in this manner expected from the large language model. But if we would train this model, I cannot say with much confidence that it will perform zero shot, but I assume that it would be as same as performant as the large language model, but we should just experiment with it with a larger data set. And for this task, we need large number of GPUs and huge compute powers.
So it's not dataset specific, right? If I have large amount of text, I can
it can be
create a knowledge base and then work with it.
First of all, we will construct a knowledge base, and then we are just using the next token prediction objective for language modeling. So it can be any unstructured text could be as given as an input to this model.
Yeah, and also some of the large language models have this multilingual capabilities. And is your approach of knowledge distillation, is it language specific as for now? Can it be extended to multiple languages? And
since we are using a larger model to perform the entity search and construction of the relations, we expect the model to be the same, possess the same multilingual capabilities as a teacher, but we must experiment with it more. I cannot say with much confidence again.
okay, thank you.
Thank you very much. More questions? Over here? I have several. Could you please return back to slide number 15, I believe.
15? Oh, sorry. Yep.
It's about knowledge graph construction, which would be a prompt to slide number 18, but this is the second question. That would be
Yes.
the second question. So my question is about knowledge graph construction. What I do see, you are just doing text to graph. So you extract triples from the unlabeled text. What is the pipeline for that?
Yeah, so we're using zero-shot capabilities of large language models.
Okay, so just prompt things.
Yeah, so
into the large language model and get some triples out.
Yeah, and here is the part of distillation process happening during the graph construction, since the model is utilized to augment the entities and the relations with additional properties. And here is a part of distillation.
This example you have in the slide is a very good prompt to look into the knowledge which is dissolved in this small set of triples. So just as Canada has regulation, PIPEDA, and Quebec Privacy Act, so it does not really say that Canada is a country, then Quebec Privacy Act is a legal act.
Yeah,
that
so
Quebec is a city and regulation is a norm.
Yeah, and this is problem we are working on right now, since the some relations can be.
I would say this is the most fundamental problem in text to graph.
Yeah.
To know about any approaches that help us bridge this gap? Yeah, we still have time.
Yeah, we should experiment, like, during the graph construction, there is no guarantee that our model will analyze all the entities. So we need to, by using only the language model in zero-shot setup, we cannot expect the model to get all the relations. So we must identify so we are thinking about the setup where we identify first all the entities inside the text, and then we are asking the model to say if this entity relates to some other entities in the list. If it relates, then how it relates to this. And by doing this, we will account for all the possible connections inside the text chunk, like first passage sample. And it would solve this problem that the Quebec is not connected to Canada.
I'm not fully sure that text chunking may help really solving this problem.
Not text chunking. So text chunking is used just to prompt the model, but entity identification via separate model will be can solve it, since.
So you have a hope that prompting the large language model you use for a concept might help.
Yeah. So to find the relation.
I definitely doubt it. Okay, I would really suggest you to take a look at the bulk of papers which research ontology building from text.
Mm-hmm.
That might help you find an idea and sort of a way to go.
Mm-hmm. Yeah, thanks. I will definitely.
If you please go to your slide number 18, there was a phrase 18. Perhaps the previous one, where you spoke about effective knowledge, effective knowledge graph querying.
Yeah.
What do you mean by effective here? What would be the measure of effectiveness?
The measure of effectiveness will be the relevancy of the knowledge retrieved from the knowledge graph by inputting it with some query. The query could be an entity, or it could be a description of an entity. And the main goal is to construct a method, separate model, which will act as a retriever from the knowledge graph, or specific embedding, which will be stored in the vector database to perform the fast querying of the relevant information. Because by using only nowadays, most of the vector databases are constructed with some embeddings from language models or some specific methods, and this is not the optimal setup, since we cannot say that in the embedding is encoded the whole context which we need for this graph. So
absolutely,
we must there are a lot of possibilities to do this, and we must experiment with multiple ones by using a separate model or existing embedding methods. They are not working as we tested it. So we were testing different embedding models for the vector database index, but the retrieved knowledge is not so accurate enough. So sometimes we retrieve some additional context which is not relevant to the question, and we need to experiment with the knowledge graph varying. So it's a huge problem because we don't need there is no specific research method which is doing it. So which is doing a performance graph varying from them with the embedding or something. So there are multiple ways to do it.
I would suggest that to take a look at the query systems which have been developed and commercially deployed for triple stores.
Yeah, we actually took a look at it, but they're pretty
So I would say that well, if you have a quality knowledge graph built, and the leaves are stored in the triple store, so there is no problem to make effective querying of such a knowledge base. There are off-the-shelf solutions available.
But okay, yeah, we will definitely take a look at it, but we are
Yeah.
not like we are just very.
This is not entirely within the community and within the field, but it's on the brink or on the on the intersection with the semantic technology community. So you might wish to take a broader look. That might help.
Yeah, thanks.
Thank you very much. Are there any more questions here? No, that was an interesting talk. Why aren't you asking? Okay, thank you very much. I will be looking for the next speaker. Our next speaker is Nazarii Drushchak. Please share your screen. Thank you. I'm very glad to introduce Mr. Nazarii Drushchak, who will be talking about the stereotypes in large language models. No. Just return back to the first slide. I do not remember the title of your talk by heart yet. Sorry about that. So I do see the application of this research aims at looking at stereotypes using demographic biases in hiring decisions. So it's a very, very interesting combination of basic research and applied research. So this work has been advised by Mariana Romanyshyn, so my thanks to her as well. And Nazarii, the floor is yours. Please go ahead.
Thank you. Hello, everyone. My name is Nazarii, and today I will tell you about the stereotypes in large language models. And this work was advised by Mariana Romanyshyn. Also, I can tell that the gratitude to apps Ukut for the scholarships and also for the computational resources, and also thanks to the Genie team because they provided the data for me, and I will tell it later about this. Plan of my work. Today I want to tell you about the motivations of this work, some related works, research gaps, also discussed as a data sets, some approaches which we created, and also early results and the future work. So if we start for the motivations, first questions that we always forgot for the what we are doing, and we only train the model and believe that it will be always better. But the if our world is biased, the model will be biased if we train on the same data. But if we a bit serious, let's check some of the examples where we use the system, and probably we use it in a really different scenario, and we can find like a really different problems. For example, like a problem that's a lawyer generated like a fake cases. Also, that the Air Canada created their chatbots, which tell some different honor refunds. This chatbot tells clients, and now they need to like working with this policy. And also what is interested is that we also try to use the models for the system in educations. For example, we use it for the STAR test. For 75% of the work will be graded by this one by the ChatGPT, and it also can find some biases maybe in the future. So, but if we will more specialized and deep dive into the topic of hiring, we can find a case about the Amazon and their recruitment tool. And this is like a big problem because this tools show really big biases and reject all female candidates, but they find it only after they're using the system. They only believe that all will be okay, and let's run like our model in the data which we have, why we should have this problem. But after some time they find it and cannot fix it, so they close the system, and only after a couple of years they created it one more time. Also, why this topic is important, we have in New York City, where they created some law that start working from this year, if I remember correctly. And they told that this that if the company use the hiring tools with AI, which helps them to tell if the candidate was rejected or approved. This model needed for the like some explanations and told why they reject, or so they need to add some feedback also. So let's jump into some related work, and it will be more helicopter view because there are different type which is really related to my work. And first of all, that we will using the generative AI. Why generative AI? Because we need to create it like an of like a feedback also and generated the answers. That's why it's not only classification, but also we need some feedback. And in general, we have different works which show the limitations and adds of the LLMs and mostly for the transformers too. Another part, it's also some responsible AI and NLP. That's a really new topic, like in general of the responsible AI, and in NLP they starting to grow mostly from the previous year, like to create a different researchers, more robust. So in the idea that they try to find some general cases of how we can evaluate this fairness, and also some challenges with mitigations of these biases. But if we also jump into the biases topics, bias mitigations topics, we can also find a couple of works which show some general approaches, how we can evaluate it, how we can mitigate this problem. And in general, we have three big groups. It's like a pre-processing, where we modifying all the data. In processing, when we try to modify our algorithms to add some regularizations or for penalizing our model to don't be unfair for some groups. And also some post-processing. And in post-processing, we mean that we can rerun our system. For example, is the hiring. We tell that we approved 5 people with different confidence. And after that, we can rescale it for different groups to have the balanced and unfair results. Also, I have like one separate work which I also want to mention to the related one. It's really new, and it was published on 12 December the 2023, and it is related to my topic, and it's like now it's like the most relevant work which told and which where they tried to measure the biases in hiring, and they use like a bit different protected groups. They use the gender, race, pregnancy, and political affiliation statuses to evaluate biases. Also, the different which they have, that they don't have they have only the candidate CV, and in general for which field they are want to go, and also they know the statuses if the person is approved or not. So it was easier for them. And what they do, they added for the CV some protected attribute. They injected it and told, for example, that this candidate is male, and after that provided all of the text of the CV and asked the model to generate the answer. Some limitations which they have is that they don't provide some job descriptions which cannot verify it by the levels, for example, for seniority levels of different candidates, because we can also don't have like biases in a level of one jobs, but it also for the seniority of the level also can be these biases. And another one that they only tested was binary representations of each group. So based on it, we can find it this part of gaps. In general, that they mostly whole researches is based on the gender. Sometimes they provided the race, but a really small number of them are providing some another attributes, for example, as a age or military status, which can be really important for us now, marital status or some another. Also, another problem that we can find that the mostly researchers are concentrated in English languages, and they don't try to work with diverse landscape. And we also can have the problems for the different languages difference, because model train and do not have the some matches in the languages. We do not tell them that this word is equal to this one and that. And when they generated answers in different languages, different results we can have. And also that's mostly all researches is related to some general topics and general how we can fix it. But for some specific area, we do not have some mitigations framework because it can be specific for some area. So what questions we created in general to how do biases in LRM vary across different protected groups? Also, like we want to does language awareness of LLM influence this fairness disparity? And in our case, we will use English and Ukraine. And also how effective public available bias detections and mitigation techniques can be used for the AI-assisted hiring system. So after that, we can jump into the questions related to the data. And first of all, some limitations and challenges which we find at first with the open source data set. And the first problems that mostly they are not really anonymized, and we have this protected groups in the text of CVs. Also, some for collecting this data sets, it's really hard due to some PIA data, which like user have in their CVs, and we cannot share this data also. What we can find some data sets, they are not collected together, and that's why we can find it some job description data set or some candidates data set, but it can be for different time landscape or ads, and it is not really correct to match it. So it will be like one of more limitations. So what we try to do, we asked Yevhenii to provide the data, and they tell that they can do this. We after that, if someone do not know what the Yevhenii, it is anonymized job search system, like services, and where we have a lots of anonymized profiles of the user, and also a big landscape of the job descriptions. What can be limited of this data set? That this data set is mostly for the IT sector of Ukraine, but we can also like check all of this one. Also, a good one that we have English and Ukrainian representations, and the data set is really big. They have 150,000 jobs descriptions and 230,000 candidates profiles, but for them, only 10% of this is for Ukrainian one. That is also a really big number. And also this paper with this data set was submitted to UNLP 2024, and it will be with MIT license, so everyone can use it. When we finish with the data set, we can jump into the idea of what we want to do. And in general, we want to evaluate biases in LLMs for 6 different groups. It is gender, race, name, age, military, and marital status. And also check it for the different languages and also compare the results of this. And after that, we want to define and try to use different mitigations techniques to know which one it's better to use in this case. And also to evaluate it and find which one's the best. So what is our approach in general? What we try to do? It is that we firstly have our data, the job descriptions, anonymized CV, and also we collected the small data set related to the protected attribute. And what we do, it's first one, we need to inject the this protected attribute to the anonymized CVs. It's like some sentences in the upper or bound parts of the each CV. And after that, we can create it like a prompt. In general, it is what we have. You are like AI-assisted hiring system. Please tell me if you will reject or approve this candidate, and please provide it some feedback. As you have this job descriptions and information about the user. After that, we only executed the model and like have this results with like reject or approve status as a binary classification, and also the feedback, because it's also important, because like we can approve two people, but with them we have the feedback which we told that it's we approve, but we don't really know it's a good idea or not. But for another we told that it's a strong approve, and we can hire this person. So after we run all of the system, we go into the evaluation techniques, and in general, we separated our techniques in 3 groups. It is like a fairness matrix, which help us to know some ratio of predicted hiring for the whole data sets for different protected groups. Another one, it is like some explainability metrics which help us to understand how consistency and how similar our results feedback here is for the candidates, because if we injected first male then female in the our CV, we have 2 really similar CVs, and we can like evaluate this consistency. And the last one is this consistency matrix. It's also try to have to find like what like difference we can find it, because mostly these protected groups cannot shouldn't somehow change the results. And if we tell the first person that is hired, all others with another protected attributes also should be hired. After that, what we can do, we try to do some mitigation strategy. First one, it is can be the pre-processing stage, and in this pre-processing is related to our prompt creation. What we can do, we can tell to ignore it or added some chain of thoughts in the prompt. Also, we can tune our parameter of the model, like temperature and that. To also, in another one, it's in processing, and it is a bit challenging for the LLMs because it's really big. It is hard to do this, but we can have some techniques as adapter tuning as LoRa, which we can change when we can tune our model for some part of our data set to tell that you do not need to have some biases related to these different groups. And another one, it is like a post-processing. In the post-processing, it's mostly like re-ask the model if they told the answer correctly, or maybe if they can find some biases in this, if you will change some informations and that. And after that, we can filter, and when we filter, we can jump one more time for the LLMs with updated prompt to find the other without the biases. What's the results we have right now? We pre-processed our data sets, and because they have also some troubles, like we also find some some PIA yeah, data which don't was deleted before. We also fix this. Also, we match the job descriptions and candidate CVs. After that, we are creating this bilingual data sets which we can use it for different LLM benchmarking, and published and submitted it to UNLP, and developed some this experimental flow and did baseline run for all of our data. And for the future one, we need to develop this evaluation framework to understand what level of biases we have. Also defined and implemented different mitigation strategies and evaluated and compared it. After that, I want to remember after my speech that we don't want to create like a model which represent only our world because it's biases, and let's pay attention and create the model of the better world. And that's all. Thanks for your time.
I'm ready to pass the mic. Questions? Yeah.
First of all, thanks for your presentation. I have a question about fairness balance in language models. Like commonly introducing more fairer outputs in LLM harms performance. For example, there is famous example with Llama 2, where if you provide a question about how to solve a task for getting cabbage, wolf, and sheep across the river, if you provide the task to LLM, it will tell you that I refuse to answer that question because it introduces harmful stereotypes against wolves. So understandably, it wouldn't provide any meaningful results. How do you see a balance between LLM doing his job and getting more fairer outputs?
Okay, thanks for the questions. In general, what I can tell is that it's based on the data for which we will fine-tune the model, and really we can have the same quality. And in general, in responsible AI, we had a paper which told about the impossibility theorem, and which told what you tell that we cannot balance this data and have the fair and good quality model. But previous year, I was my colleagues write a paper which told that we can do this, and for it's related also to depends on the data for which we tune it, and also which small trade-off we want to have, because we don't want to have like a real ideal model. We can have like some boundary for the fairness and have this good quality. So it can be like from, I don't know, for the disparity from 0.8 to 1.2, we have the fair model, but we do not have the big gaps in our quality of the model.
Thanks.
Yes, thank you, Nazar, for the presentation. I have also some questions for you. Yeah, first of all, yeah, could you please briefly give a definition? What is demographic bias? What is bias? I didn't hear it during the presentation.
Okay, it is in general naming. We can name it as a bias as a problem, and demographic biases it can help us to understand that we're working with the data, which can more related to the person, like age, name, and that.
Mm-hmm. Okay, thank you. Yeah. So the next question is. In your slide, I noticed that the first idea is to investigate the bias and then mitigate it. So your assumption is that there is no, so all models are biased, right?
Yeah, and we check it manually. So we have, so we for now we do not have like the some numerical representations of these biases because we are in the part of creations of this like flow for the this, but we manually checked and we have these troubles. For example, we put a different religion and they put for one for the Buddhism, they told that we will hire this person because we need some diverse. But when we put like Christian, we told that, and they told we cannot hire it because it can be some troubles with the religion and that.
Okay, I see. Then maybe it would be good to include such a qualitative example as well to give a better context. And then, so what type of LLMs are you going to use in your research?
Okay, thanks. In general, we want to try GPT 3.5 as one of the most robust for now because we want to do it for the two languages and using some open source for now. It's hard to find which really good with Ukrainian. And due to the computational resources, we cannot run like really big one. And also we want to use the Phi2 model only for the English languages because we want to try to run it like some tuning process in processing, which hard to do with GPT.
So do I understand correctly that this if you do an investigation if the model is biased and then you say you found that it is biased and your mitigation strategies will they be like model specific or you say design a set of mitigation strategies and then you can apply them to any LLM model?
It will be, I think it will be more model specific, but this research can help to understand which techniques it's better to use for this type of task and which not, because in general, models trained in really similar data, but some changes can be. But if we will have the result, for example, if we told about chain of thoughts and it will have as a result, I don't know, 0.8 of quality or fair. And when we will use another one for the telling that do not check some protected groups in this prompt, and it will have 0.6, which is really a smaller number. And then we can understood that this techniques is not working at all, and for different LLMs it's a big problem.
Yeah, and the last couple of questions related to the data set. So you created your own data set, and like what is the ground truth there? So you have say you have a data set of a job description. So what is the ground truth, like hire or not to hire?
It's like some limitations of this data set, but for us it's not a problem, because we want to try to find like the balance of the results. We run the experiment for a different group. For example, I don't know, for some race, for example, we run it for the different one and find the majority, which we told that it's like the result if the person should be hired or not. And only that we try to find the biases when we tell the another results to
Yeah, so maybe my next question related to what Yurii was asking. Usually the model has some level of performance, and if you do the bias mitigation, it like may drop, and you don't have this ground truth level of performance. So like
for training.
eventually your model will be fair and it will have some performance, but like what is the baseline to what we can compare it?
We can create it from the basis without any injections. We can run the model and have their results. So we collected it, and only after that doing these injections, telling that, for example, this person is male, this is female, and provided this baseline output for each as correct one.
Okay, and the last question, what is the distribution of Ukrainian English job descriptions in your data set?
Yeah, it is 90% of English and 10% of Ukrainian, but it's also a big part because it is really big data sets. And for example, for the candidate, it will be 23,000.
Okay, thank you. Then it would be also nice if you could include that into the presentation as well.
Yeah, it was only approved for the UNLP, and I cannot have a lot of time to edit.
Okay, thank you.
Yeah, Rostislav.
I have a very brief question, actually, which continues the last one of Ruslan. I understand that there are job descriptions in 2 different languages, but CV resume, actually, it's so short that it doesn't matter what language it is in. You mentioned it. The results you want to study.
People also provided CVs in different. It can be really short, and some of them it's longer.
Yeah, but I mean the information put there is so language agnostic. Actually, it translates actually without any.
Yeah, but model do not have this like a good correlation between models, and they have worked with one model as one, and with another language another. And I only also tested like the same CVs. I translated it and tried to run it into both languages, and I have a different results. And it's also a problem of, and it's problem related to the some scarcity of the data for some languages, and that's why the results can be different. That's why
it's surprising because if you list the skills, they will even if the resume is in Ukrainian, these are the same abbreviations.
Because they not only the skills, they also provided like some text informations, what they do, what the project's about, for example.
Okay.
Questions from the audience? Okay, I voluntarily, autocritically reserved 2 questions for myself. My first question about cross-lingualities. Just imagine that a Ukrainian CV applies for an English job description or vice versa. Are there any cross-lingual biases you have identified?
For now, we do not do this. It will be as limitations of our work. And also we do not try to do some combinations of different protected groups, because it's like too many experiments which we will have, and
And for that, you
really
need to
interesting.
have a really balanced data set.
Yeah, yeah.
Okay. Thank you. My perhaps last question is about your slide number 21. This is about the real world versus ideal world. I'm really interested in who are the we and how broad is the group?
Where is the we?
Because for me, it looks like a dictatorship, isn't it? Philosophically.
Yeah. In general, we is who develops the system.
Oh, yeah. Oh, yeah. That's what I expected to hear. So how broad is the group? And are you really looking for this sort of an impact?
It's also the
Just
question.
building the world you want to see based on the hiring decisions.
Yeah, in this case, we also have the another part of axiom in a responsible AI that whole team should be diverse. So we cannot create some system which should be
come on, the sample would not be really representative anyhow compared to the size of the humankind.
But we have also human feedback.
Okay, that sounds better. Sounds better. Okay, thank you very much. More questions? No, everyone is looking forward to the coffee break. Okay. It's my pleasure to announce that the coffee break is ready for you. So please go ahead and take a coffee.